7-4 today. We're going to be solving trig equations. And 7-4 is actually in two parts. This one I think is called set 1. And then the next one obviously is going to be called set 2. So really this week is devoted to one job, and that is solving progressively more difficult equations. And I'm going to focus for the most part on solutions that are in the unit circle, which we obviously have here, right? So I'll be bringing this guy back and forward from time to time. We're also going to be looking at all the solutions to a trig equation that exists. Now, one of the things that trig equations do that typically you wouldn't expect in a normal situation, and that is that trig equations have an infinite number of solutions very often. I'll give you an example. If I said to you, the sine of theta was equal to 1/2, that's essentially an equation, right? Solve for theta. Well, you would say theta would be the inverse sine of 1/2. And so I go to my unit circle and I find out, let's do the answer as radians, because they want radians today. And so we would say that that is a solution. Would you agree? Would you also agree that there's another place where the sine, the inverse sine is 1/2, and that's over here? So wouldn't also phi 6 pi count as a solution? And as long as you're only going to do a solution in a fixed range, like only angles from 0 to 2 pi, that would be the solution. But if you allow theta to be any number, wouldn't pi upon 6 plus going round the entire circle once, so adding 2 pi, wouldn't that one also work? And could I add another 2 pi? Forever. So essentially, aren't there an infinite number of solutions? There's pi upon 6 and any multiple of 2 pi you like. So add 2 pi, add 4, add 6, take away 2 pi, take away 4 pi, take away 6. Same thing's true for this one. So how do they get us to write down an infinite number of solutions? They use this trick. You write that guy, and then you write that guy. So a lot of your answers today are going to look like this. And you're saying, what on earth is this 2n pi? N is a whole number. In fact, n is all the whole numbers, right? 0, 1, 2, 3, 4, 5. So if I stick 1 in there, won't you get 2 pi? If I stick n is 2, won't you get 4 pi, 6 pi, 8 pi, 10 pi? So your two initial solutions will now turn into those guys. What that represents is every solution in the universe to the equation that the sine of theta is 1/2. Are we okay with that idea that there's now going to be an infinite number of solutions, right? Because we're not making any restrictions. And we're saying theta is this guy plus any multiple of 2 pi you like, or this guy plus any multiple of 2 pi that you like. Are we good? Right, so we're going to now focus on solving trig equations. And once we've got these guys, we're then going to turn them into the final answer, which is this guy. Right. So we're only dealing with trig equations with essentially sine x, cosine x, tan x, whatever going on with them. So start off with with our first guy, number 1. And the equation that we're going to solve is that trig equation. And a lot of the techniques that you use for solving equations exist here. That is, as long as you do it to both sides, it's okay rule. So in a trig question, don't you want to isolate the cosine x? So I'm adding 1 to both sides. Now, to get x, I will take the inverse cosine of 1, and I will find in radians when you get an x coordinate of 1. Oh, and by the way, up here in the questions, they write down something like this. I guess they should write x, but they didn't always do that. So you notice they're not allowing me to equal 2 pi. It's 0 up to, but not including 2 pi. So when I look at this guy, would you agree that x equals 0 radians is my only solution? Now, if you want to get an infinite number of these, don't you add that 2n pi thing? So far, so good. Now, you wouldn't really write 0, wouldn't you just write 2n pi because it looks prettier? That's the answer they're looking for. Let's try another one. Suppose I went and said to you, I would like to know sin x, take away, yeah, I'm trying to think of one that I haven't done yet. Root 3 on 2. There we go. Then you would add root 3 upon 2 from both sides. And you're looking for a y coordinate of root 3 upon 2, which is pi upon 3. And you'd look for another one, which is what, 2/3 pi? So in this case, you see how there's 2 separate solutions, right? Most of the time you're going to get 2. This one is. Now, that's the answer in this, unit circle range. So all you then add on is that guy and that guy. And we're done. You see there's 2 distinct family of solutions here. 1/3 pi, and then add as many 2 pi's as you like, and 2/3 pi. Let's try a version of 2. 2 cosine x plus the square root of 3 equals 0. Okay, as long as you do it to both sides, it's okay, Ro. Tell me what I should do to both sides.
Subtract the square root of 3 and then divide by 2.
Correct. Subtract square root of 3 from both sides. And then divide. So the angle x that we're looking for. Actually, I'm not even going to write inverse cosine. I mean, you only do that if you were going to use your calculator, right? If I'm going to use my unit circle, can't I just go from here to the answer, right? So what am I looking for? I'm looking for an x coordinate of negative root 2 upon 2. Now, if I look for a negative root 2 upon 2.
3/2.
Right, I see 3/4 pi. Is there any other place in the unit circle where the x coordinate is that as well?
How did you get negative root 2 over 2? Wouldn't it be negative root 3 over 2?
That's what I was thinking.
Oh, shit in space. Yes. That was the correct answer for the question I gave you, but the question I should have gave you is negative root 3 upon 2. So what does that look like? Negative root 3 upon 2. Would you agree it's 5/6? Right, back to my... God, this is not as hard as I'm making it. Isn't there a second answer as well? Right. What's the angle that also works? I've got this one, but what's the other one?
7 pi over 6.
And don't we then finish with that guy? And what that does is gives us all the solutions in the universe, not just the ones from 0 to 2 pi, but the 22 pi ones, right, going around the circle 12 times, whatever it might be. So far, so good. The little hiccup. Yes.
So on the homework for number 1, it says a smaller value and then the larger value.
Right. But there wasn't a larger value. What, didn't we only get one answer?
That's what I thought. Okay.
Right, so what you have to do is put none in capitals.
Fine.
So it says if there are any unused answer boxes, in which case there was in question 1, you just put none. Right. Most of the time, both boxes will get filled, right? Or all 4 if it's a 4 situation. Which does bring me to question 3. We are going to solve this trig equation. And there's going to be 4, there's going to be 4 distinct boxes for the answers. And all 4 of them are going to get filled. Sometimes they'll give you a question with 4 boxes and only 2 of them get filled, right? Right, there's only 2 solutions. Then just fill in none and none for the other 2, right? If that happens. But in this case, I do know they're going to be 4. 2 cos squared x, take away 1 is 0. As long as you do it to both sides, it's okay, Roll. Let's do some things to both sides then that gets this closer to being solved. What should I do first to both sides? And there's only one thing you can do. That's actually a clue.
Add 1.
So adding 1 to both sides gets me to there. What should I do next? Remember, the goal is to get cosine x on its own eventually.
Divide by 2 and take square root.
Okay, so we'll divide by 2 and get that. And then you said quite rightly that you're going to take the square root. Now you've got to be careful with square roots. When you take the square root of both sides, technically, isn't there always a possibility at least of a plus and minus? And in this case, there is a plus and minus possibility. But that guy can be made prettier. 1 over the square root of 2. Are you okay with that? Square root of 1, square root of 2, right? I can make that better. If you multiply by root 2 upon root 2, don't we now get root 2 upon 2? Are you comfortable of how there ends up being this guy? And this guy is the one I wanted because this guy I can find in a unit circle. If I left it like this, wouldn't I be thinking, I can't see that guy in here? But I can see this guy, right? Now, there's technically going to be 2 situations that we have to deal with, each on their own. They're going to have to be the situations where the cosine of x is that, and then the other one is when the cosine of x is equal to that. So let's focus one at a time. So forget about that guy for a minute. I want to find out what angles have a cosine of negative root 2 over 2. Well, if you do negative root 2 over 2, would you agree you get 3/4? Is there another place in the unit circle where the cosine is negative root 2 over 2? And where is that other place?
5/4.
Great. Now forget about that guy and focus here. Well, there's a place where the cosine is root 2 upon 2. It happens to be pi upon 4. And there's another one. And the other one is way over here somewhere, and that's 7/4. And the 4 answers that we're meant to write down in these boxes, because WebAssign is not too bright, they want you to do it from smallest to biggest. So I'll take that guy. That's 1/4 pi. Then the next one after that is 3/4 pi. Then the next one after that is 5/4 pi. And the last one is 7/4 pi. Now you come to about, there are 4 answers, but you have to kind of mix and match them from smallest to biggest. And the bit that's probably just forgettable, since we want all the answers in the universe, don't we finish with that? plus 2n pi thing that, adds 2, 4, 6 pi to the answer. There's your solutions. There are 4 of them. How are we doing? We good? Any questions before we look at another situation? Okay. Let's look at an equation that looks like this. I want to solve this equation. The sine of x times 2 cosine x minus 1 equals 0. Now what we have here are 2 things multiplied equals 0, essentially factored. Right. Now if I'd given you x plus 1 times x minus 7 equals 0, wouldn't you be able to solve that pretty easily? We're going to do the same thing. If you have 2 things multiplied equals 0, then the math says that the only way that can happen is if the first thing is 0 and or the second factor is also 0. Are you comfortable with the logic of how to solve this? Basically boils down to solving this. Does that make sense? 2 things multiplied are 0, each piece could be 0. Now if you do this fella, you're going to get the answer 0, and you're also going to get the answer pi. You are not going to get the answer 2 pi. And the reason for that is that they do this nothing to 2 pi thing, but don't use 2 pi. And you might say, well, what's going to happen to 2 pi? Nothing much, because if you add 2n pi to these guys, won't this guy become 2 pi when n is 1? Won't you get 0 plus 2 pi? So it's not like you lose a solution, you just don't need to write it, right? You only need to write 2, like the first 2 that you make. Now this fella here, if you want to see the working for it, you would add 1 to both sides, and then you would divide by 2. And you're looking for the 2 places that you got a half. So this would be pi upon 3 and at 5/3 pi. And each one of these then gets that 2n pi thing tagged onto it. And this is another one of those 4 possibilities. That guy, you wouldn't write 0, you would just write 2n pi. And then the next one is 1/3. And then it's pi. And last but not least, it's 5/3. So you write them down from smallest to biggest. And that's just to keep WebAssign happy. I guess it's difficult if you jumble them up.
I have a question.
Yes.
So is that a version of problem 4 then?
Is that a version of what, Anthony?
Question 4.
Yes.
So how come in question 4 it only has 2 answers then versus we got 4?
Well, it must be that some of the answers are either duplicates or they don't exist. In other words, there isn't
Okay.
an answer, right? Let's do a version of question 4 then.
Professor, when we're typing in the UN pi in a WebAssign,
Yes.
what symbol do we use for the N, or do we?
Oh, I think you can, oh, they're
For me,
using,
it's actually a K.
they're using a K. Okay, so it's just the letter K in the alphabet.
Okay.
I'm using n because I'm just used to n. I didn't even pay
That
attention.
threw
to
me
it.
off because I entered n in multiple different combinations until it said I couldn't try it anymore. And then
Okay.
realized, oh, you're supposed to do k.
It's K. Yeah. Moral of that story, read the question, right?
Yeah.
N and K, I guess. I don't know why they use K. I use
I was
N.
trying to figure out if the n is supposed to be capitalized or
Nah.
any of that kind of
No, it's just K. And it's a little K. So,
I have another question about that.
mhm.
So they have it as 2 pi k. What if we do 2k pi? Is that gonna make a difference?
Mathematically, that's exactly the same thing. Does it take it?
I don't know.
It doesn't. But I mean, it's mathematically correct. So 2 pi k, 2k pi are equally nice looking. I wouldn't do some of the other weirder combinations. Right, would you agree that those two don't really look good? Technically, mathematically, they're also
I
the
just
same.
tested it out and
And
it took 2 of the answers and the other 2 it didn't take.
is this question 4?
Well, this is question 3. I was just typing it in to see if it would take the 2k pi, and it only took 2 of them out of 4.
Did you?
It has the right
Happened
answer
for
right
me
next
with
to it.
question 1.
Well, question 1 only had one answer and the other says none. That's what I'm looking at here. Okay, let me just try that out. Let me go in as a student and do a question. Okay. Let me see if I can make that happen. Give me a few seconds to set the thing up. I'll go in. Right, I'll show you student view and we'll do one of those questions. And that way we can figure out what WebAssign can handle and what WebAssign can't handle, right? It'd be interesting just to find out. Right, are you looking at our 747 set 1, set 2 and trig equations? Is that what you're seeing on the screen right now? No? You seen it now? Okay.
Yeah.
So I'm going to click on this one. I'm in student mode, so things might look a little bit weird, but that's fine. Right, the one I'm going to do is this one, right? So this one is sine squared x is a half, so sine x is √2 upon 2. And if I look for the places where the y coordinate, because it's a sine this time, because it varies the questions, doesn't it? So when is the sine of x equal to square root 2 upon 2? Pi upon 4. So I should be able to just do pi upon 4. It's so weird. Let's just do Greek letters. There, that looks nicer. Pi upon 4 plus 2 pi k. Yeah, they want it written as 2 pi k, so let me do it
If you
their
could-
way.
yeah, do it the other way.
Right, there's one of our answers, okay? So I'll submit it and see if it takes that one. Yep, so it likes it that way around. Another answer we would have got would have been 3/4 pi. So let me take this answer and put in 3/4 pi. But let's switch that round. Okay, so second try. Yeah, it seems to be happy with either 2k pi or 2 pi k.
Do one more.
So there's 2 more. So next one would be 5/4, right? So let's check that one out. I'll just make that a 5. Check it out. It's good. Oh, I think I've run out of shots. 7/4 should work if I hadn't run out of shots, because every time you do it, if you don't fill in all 4 in, it counts as a guess, even though you didn't really put anything in, it still counts as a guess. I'm pretty sure 7/4 also work. So I don't know what happened. But let's return to that question. What question was the one you were having trouble with? Because Cassandra, maybe I should do it. Was it question?
No, I went back. It was the same. It was number 3, but I went back and looked at it, and it's because my plus sign was missing when I typed it in.
Oh, okay. Well,
So-
I've never done anything like that before, so I find it very hard to understand why you students make mistakes, because I'm perfect. In fact, do you know I used to be conceited, but now I am perfect? Oh, come on, that's a good one. I'll try that again. You didn't catch that one, Lanny. You know I used to be conceited, but now I am perfect. This joke is dying here.
We're
Could
all
someone help her out
muted.
and
I
explain
giggled.
why that's meant to be a joke?
Look, even Lana's giggling. We're just muted. It's fine.
Okay. You got it then, Lana, right? Jacob, did you get
Yeah,
it
I
the
got
first
it.
time?
It took me 2 tries, but
Yeah, it took her 2 tries. That's better. Jacob, did you get it the first time?
Yeah, I
I
got
was
it.
gone pooping, but I had my headphones on. Yeah, it was good.
Okay. God, you poor lot, what you have to suffer. It's bad enough doing trig. Well, trig's fun, but you know, it's bad enough doing math and having to suffer me. Okay, this is the guy we've got, right? It's another one of these product ones. So we're dealing with 2 things multiplied to 0. So evidently there's only 2 answers to this one, which is what the original, I can't remember who it was, but someone said, how come there's only 2 here, not 4? Because there was 4 in the previous, right? Well, let's find out. I don't like any trig identity that's not sine, cosine, and tan. Because if it's not sine, cosine, and tan, isn't it hard to use the unit circle? Now, do you know what the cosecant of x can also be written as? In terms of one of the other trig guys, what's the cosecant? It's, say again?
1 over sine.
1 over sine. Now, I'm trying to find a value for sine x that if you take that number and divide it by the value of sine x, you get 0. I know 1 over 0 doesn't work. Like, that's 1 over 0 is actually infinite, it's not 0. If I reverse this, it's even weirder looking. If you think of 1 divided by 0 as being infinity, right? Would you agree there is no angle where the sine is infinite? Aren't the sines only going to take numbers from 1 to -1, right? They're in the unit circle. So that means there are no solutions. So this guy just didn't give me any. Right? That's why there's only 2 boxes instead of the typical 4. Now this fella, can I jump straight to its -1/2? You know, you can fill in the gaps. If we then look for some places where the cosine is -1/2, I'm looking for an x coordinate of -1/2. And so I'm going to get 2/3 pi and an x coordinate is -1/2. I'm going to get 4/3 pi. And it's so easy to forget. I was about to, but now I'm going to remember the right letters. There's the 2 solutions for the 2 boxes that you do have. Are we cool on that? Right. Let's do a version of 5. And this is a made up version, so it's not really exactly like 5, but it has some of the features. Two things multiplied. So we're going to have that guy is 0. And the other situation is going to be solving to make that guy 0. Let's do this one, because this one is kind of sneaky. I'm going to subtract 3 from both sides. Then I'm going to divide both sides by 2. Is there, and notice the way I'm phrasing this, is there an angle in the unit circle whose x-coordinate is -3/2? Can you actually get a cosine equal to -3/2? No. So that means there are no solutions. That just ain't going to happen. Now, on the other side, 2 cosine x, if you add √3 both sides, and then you do cosine x, you get that guy. That guy does have 2 solutions. And one of them is pi/6, and the other one is 11/6. And then you just add in your 2 kpi's. Now, if they give you 2 boxes, that's good, right? Put that one in there, put that one in there. But because they change the situations, you might get 4 boxes. So what do? You put capital none and none in the 2 vacant ones, right? So if there is only 2, smallest, biggest. If there's 4, smallest, medium, biggest. If there's only 2, couldn't you get a question where there was no solutions at all? Then wouldn't you just have none, 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 right? So that's what your answers would look like. So you might get a version of 5 with 2 answers, as I did. You might get a different version of 5 with 4 answers. Can you imagine if you tweak these numbers, you might get a solution that does work, right? And so even if you phoned a friend, they would say, yeah, I've got 4 answers. And you'll say, well, I can only get 2. I must have done something wrong. No, couldn't you just be the person who got this question? And that's okay. Right, we haven't done any quite like question 6 now. Square root of 3, the tangent of x, times the sine of x, plus the sine of x equals 0. Now, when you get questions that have multiple terms with sines and cosines, in this case, sines, cosines, or tans, right? Anything that looks like that, you're going to have to do a bit of algebra before you start thinking about solving. So I want you to think about factoring, and in some cases changing, but in this case, factoring. Is there a common factor you can use in this question? Is there a common factor in this term and that term? I think there is. What is it? Say it again.
Sine.
Yes. So far, so good. So what we have to do is we have to do the factoring ourselves. The earlier questions, weren't they already factored? So you didn't worry about it, right? They'd already done that job for you. Now we have to do that job, right? They're making it a little bit harder each time, right? Now we'll take this one here, which I think is the easier of the 2. We got that guy. And if sine x is 0, you get 0 radians, and you get pi radians. And then you can add your 2 kpi's. You don't bother putting 2 pi because 2 pi doesn't get used. Remember that 0 to x to less than 2 pi thing, right? Yeah. Let's solve when is this 0? Well, if you take 1 away from both sides, you get that. If you then divide both sides by the square root of 3, you get that guy. And nope, you don't need to fix that guy. Actually, if you try to fix that guy, I think it wouldn't help. It'd probably hurt. So we are looking for an angle whose y coordinate divided by his x coordinate is -1 over root 3. So we're looking for a y coordinate divided by an x coordinate. And the answer has to be a negative fraction that looks like that. Well, I can make my life a little bit easier by only looking at places where the answer has to live. Since this tangent is negative, which are the 2 quadrants where the angle x has to be? Because there's only 2 places where the tangent is negative. So 1, 2, 3, 4. Give me one of the quadrants where the tangent is negative.
2.
Okay, so let's just focus on this quadrant, right? Forget everybody else for a minute. Just this quadrant here, right? Can I hide that? There we go. We'll touch that guy hid. And that guy hid, right? The less to distract us, the better. Now, I want to take the y coordinate and divide it by the x coordinate and get a 1 on the top and a root 3 in the bottom, right? That's our goal. 1 on the top, root 3 in the bottom. There's your candidates. Which one of those gets you a 1 on the top and a square root of 3 in the bottom? And remember, y is the top, right? And the x coordinate is the bottom. Who is it?
5 pi over 6.
Right. If you rub out the 2's, it's a little bit easier to see the y and the x. Because the 2's cancel out anyway. You see it? y1, x2. So that was 5, 6 pi. Probably made a meal of that, but it's worth it. Okay, where is the other quadrant going to be? Where else is the tangent negative? Which quadrant?
4.
Okay, so let's just focus on only the 4th quadrant, right? Same thing. Y divided by x gets you 1 over root 3. Forget about the negative, we figured that out. Which
Plus
one of
pi over
those?
6.
Agreed? Right, you all agree it's that one? I've covered up the 2's, can you see it? -1 over root 3. Okay, that's the end of our quest. We found everybody. We've got these 2 guys here, and we've got these 2 guys here. In case I forget, you do that. And you do smallest to biggest, so that one's first, that one's second, that one's third, and that one's last. Any questions?
I do. In the beginning, since tan times sine of x, could that just have been cosine?
It would be, but if you did that, the equation wouldn't be very easy to solve. Because what you'd have is the square root of a cosine plus a sine. And you say they don't play well together, do they? Right. So you really want to just have them as 2 things multiplied. So what you said is correct, Matthew, but it wouldn't help you to solve the question quite as quickly as it should be.
But wouldn't that be sine squared x over cosine, not just cosine? 'Cause-
Yes, and that's even worse, isn't it?
Yeah.
Yeah. I'm looking at why there's only two answers here. Oh, I fell for it.
That's what I fucked up. Fuck.
There is only two answers, right? Two of these guys. And they did this to me, the little darlings. You see, they told me I could only use 0 to pi this time, which meant those two answers never get counted. Oh, they were nasty. Couldn't they do 0 to 4 pi and catch me out again the next time? So that tells me I can only use those two, right? The 0 and the pi upon 3. If it had been this one, which every other question was, they'd get 4 answers. Interesting. So I'm now going to read the next one. And that is question 7. And this will be our last one for today. And question 7. Oh, now you're back to where you always were, right? So we're back to that one. Now, this fella looks, well, I won't say impossible, but it certainly looks weird. Because the only real strategy that we have in these situations is factoring. But if you look carefully, there isn't a common factor. But nonetheless, this can be factored. If you look really, really closely at it, isn't this really like a quadratic? You know, like a 2y squared plus a y minus 1, right? And this is, in fact, a quadratic, but it's not a quadratic in x. It's a quadratic in sine x. So how does that work? Well, you're going to have a 2 sine x, and you're going to have a sine x. Right? Rather than x and 2x, you're going to have x and 2 sine x. Now, I need two numbers to give me -1. So obviously one's going to be positive and the other's going to be negative, right? So I guess I just need to figure out which one is plus and which one is negative. And won't the right one be whatever you get when you FOIL it? Shouldn't you end up with +1 sine x? Okay, where does the plus and minus go so that when you FOIL this out, you end up with this expression? There's only one situation that does that. Which one gets a +1? Which one gets a -1?
Positive goes in the first one and negative goes in the second one.
So you want to put the negative here and the plus there? Is
Other
that
way
right?
around.
You want to put,
So it's plus negative.
you want to write that way?
No, other way.
Okay. You want to do it that way, right? Okay, since there's only two ways to do it, let's check out which one works. 2 sine x times sine x gets me 2 sine squared x, that's good. 2 sine x times this one gets me -2 sine x. 1 times that guy gets me plus sine x. And that guy times that guy gets me -1. So I end up with 2 sine squared x minus a sine x minus 1. Do you see that one actually didn't work? Okay. Can you trust me if you do this one, it does work? And you can do that. If there's only two choices, can't you just pick one? If it works, keep it. And if it doesn't, you know it's the other one. I mean, you can certainly do that. So back to this question, that means that we're looking for when does that equal 0? And since we're running short of time, that's when is the sine of x a half? And I'm looking for places where the sine x is a half. And so I'm going to get pi upon 6. And then there's the other place is over here. And I'm going to get 5, 6 pi. And then the other half of the puzzle is when is the sine of x plus 1 equal to 0, which becomes when is the sine of x is -1. And the sine of x is -1 where? So where is the y coordinate? Where is this y coordinate? -1.
3 pi over 2.
Would you agree there's only one answer to that one? Right, in the unit circle, there's only one. So in this case, it looks like there are 4 boxes, but only 3 guys that exist. So the smallest one is this one. So pi upon 6 plus the 2k pi guy. And the next number is this one. So that's 5, 6 pi plus 2k pi. Third one is this one. But since they give me 4 boxes and you don't leave them blank, you put none in the 4th box. Right. I got a thumbs up there. Good. Right. Well, that's all we have time for today. So last name and bye-bye. I'll try and hang around for any quick questions.
I just have a quick question.
Yes.
If you want to go back to our number 6,
Uh-huh.
um,
There it is.
so in that case, if it was 0 to pi, would we have 3 answers then? Because we would have 0, pi, and then 5 pi over 6.
You said 5 pi over 6, right from here?
Yeah.
Yeah. And so
So
the 2
we're-
answers that we can use, because they only let us use that guy, the 2 answers I'd be using is actually this one, and I'd be using this one. So that's the 2 that we should have used.
Oh, because it doesn't include.
This one almost made it, but get kicked out because it's less than. And this one is just no chance, right? It's too big.